Since we've previously covered open source tools for data science, let's look at the commercial options you'll find in many enterprise projects. Take another look at the overview of different tool categories. Since cloud products are a newer species, they follow the trend of having multiple tasks integrated into a single tool. This especially holds true for the tasks marked green in the diagram. Let's start with the fully integrated visual tools category. Since these tools introduce a component where large-scale execution of data science workflows happens in compute clusters, we've changed the title here and added the word platform. These clusters are composed of multiple server machines, transparently for the user in the background. Watson Studio, together with Watson OpenScale, covers the complete development lifecycle for all data science, machine learning, and AI tasks. Another example is Microsoft Azure Machine Learning. This is also a fully cloud-hosted offering supporting the complete development lifecycle of all data science, machine learning, and AI tasks. And finally, another example is H2O Driverless AI, which we've already introduced in the last video. Although it is a product that you download and install, one-click deployment is available for the common cloud service providers. Since operations and maintenance are not done by the cloud provider, as is the case with Watson Studio, OpenScale, and Azure Machine Learning, this delivery model should not be confused with platform or software as a service, PaaS or SaaS. In data management, with some exceptions, there are SaaS versions of existing open source and commercial tools. Remember, SaaS stands for Software as a Service. It means that the cloud provider operates the tool for you in the cloud. As an example, the cloud provider operates the product by backing up your data and configuration and installing updates. As mentioned, there is proprietary tooling, which is only available as a cloud product. Sometimes it's only available from a single cloud provider. One example of such a service is Amazon Web Services DynamoDB, a NoSQL database that allows storage and retrieval of data in a key value or a document store format. The most prominent document data structure is JSON. Another flavor of such a service is Cloudant, which is a database as a service offering, but under the hood it is based on the open source Apache CouchDB. It has an advantage. Although complex operational tasks like updating, backup, restore, and scaling are done by the cloud provider, under the hood, this offering is compatible with CouchDB. Therefore, the application can be migrated to another CouchDB server without changing the application. And IBM offers DB2 as a service as well. This is an example of a commercial database made available as a software as a service offering in the cloud, taking operational tasks away from the user. When it comes to commercial data integration tools, we talk not only about extract, transform, and load, or ETL tools, but also about extract, load, and transform, or ELT tools. This means the transformation steps are not done by a data integration team, but are pushed towards the domain of the data scientist or data engineer. Two widely used commercial data integration tools are Informatica Cloud Data Integration and IBM's Data Refinery. Data Refinery enables transformation of large amounts of raw data into consumable, quality information in a spreadsheet-like user interface. Data Refinery is part of IBM Watson Studio. The market for cloud data visualization tools is huge, and every major cloud vendor has one. An example of a smaller company's cloud-based data visualization tool is Datamere. IBM offers its famous Cognos Business Intelligence Suite as a cloud solution as well. IBM Data Refinery also offers data exploration and visualization functionality in Watson Studio. Again, these are just some examples of a rapidly changing and growing commercial ecosystem among a huge number of established and emerging vendors. In Watson Studio, An abundance of different visualizations can be used to better understand data. For example, this 3D bar chart enables you to visualize a target value on the vertical dimension, which is dependent on two other values on the horizontal dimensions. Coloring enables you to visualize a third dimension. Hierarchical change bundling enables you to visualize correlations and affiliations between entities. If sufficient, a classic bar chart can do the job as well, whereas a 2D scatter plot with a heat map shows two dependent data fields, one on the y-axis and one as color intensity. A tree map shows distribution of subsets within a set. The famous pie chart does the same but in a non-hierarchical manner. And finally, a word cloud pops out significant terms in a document corpus. Model building can be done using a service such as Watson Machine Learning. Watson Machine Learning can train and build models using various open source libraries. Google has a similar service on their cloud called AI Platform Training. Nearly every cloud provider has a solution for this task. Model deployment in commercial software is usually tightly integrated to the model building process. Here is an example of the SPSS collaboration and deployment services, which can be used to deploy any type of asset created by the SPSS software tools suite. The same holds for other vendors. In addition, commercial software can export models in an open format. As an example, SPSS Modeler supports exporting models as Predictive Model Markup Language, or PMML, which can be read by numerous other commercial and open software packages. Watson Machine Learning can also be used to deploy a model and make it available to consumers using a REST interface. Amazon SageMaker Model Monitor is an example of a cloud tool that continuously monitors deployed machine learning and deep learning models. Again, every major cloud provider has a similar tooling. This is also the case for Watson OpenScale. OpenScale and Watson Studio unify the landscape. Everything marked in green can be done using Watson Studio and Watson OpenScale. OpenScale will be covered in a later video. You've learned how the most common tasks in data science are supported by commercial cloud tools. Integration provides us the ability to use the same tools for multiple tasks. In the next videos, we'll look at packages, APIs, datasets, and models for data science.